What I'd like to talk about today is random variables, and specifically how to find the mean and the standard deviation of a random variable. What I've got here are two random variables, x and y. X can take on three values, 1, 4, or 7. 45% of the time, x is 1. 30% of the time, x is 4. And 25% of the time, x is 7. Now, I have this other random variable. Let's call it y. It can take on two values. Y could be 2 or y could be 6. 80% of the time, y is 2. 20% of the time, y is 6. So let's talk about how to find the mean and the standard deviation of these. To find the mean of this random variable x, what I need to do is take the sum. I need to add all of the values of x, 1 and 4 and 7, times their corresponding probabilities, 45, 30, and 25%. And I just need to add all of those together. So if I wanted to find the mean of x, what I could do is take all of those x's, multiply them by those probabilities, and add them together. So I would do 1 times 0.45 plus, because it's sum, 4 times 0.3 plus, and then the last one is 7 times 0.25, since it's 7 25% of the time. Now when you work that out, it works out to 3.4. So the mean of this random variable x is 3.4. Now you kind of need to know that mean to be able to calculate the standard deviation, because the standard deviation of this random variable is given by the square root of the sum of all those values of x minus the mean, which is 3.4, squared times the probability. All right, so that's a little bit more involved. So let's see if we can find that standard deviation. And I'm just going to abbreviate that as S for the sake of room here. So I want the standard deviation of all of these x's I'm going to do the x, in this case 1 minus the mean, 3.4. I'm going to square it, and I'm going to multiply it, so times the probability associated with it, so 0.45. And what I need to do is I need to add to that the same calculation, but for this 4 and the 7. So now I'm going to do 4 minus 3.4 times the probability of getting a 4, which is 0.3. And then I need to add to that the same calculation, but for 7. So 7 minus 3.4, I'm going to square it, times 0.25. And when you work that out, you add it all up, got to add it all up and then take the square root. And when you work it out, it works out to be about 2.44. All right? So that's the standard deviation of x is, we could probably do it like this. Do it with a subscript. The standard deviation of x is 2.44. Now, if you happen to have a TI calculator, there's a nice little way to check this. If you go to let me just expand my screen a little bit here. If you can pull up the lists on your TI calculator, that'd be under Stat, and we want to just edit. In list 1 should just be the x values, so in this case 1, 4, and 7. In list 2 are these probabilities, so 0.45, 0.3, 0.25. And if you go over to Stat, Calc, and it's one variable stats, you just have to specify that you've got your values of x in list 1 and you've got those probabilities in list 2, it'll actually calculate this mean and standard deviation for you. So the mean, x bar, is 3.4. Standard deviation is 2.44, just like we calculated, but with more values there, or more decimals. All right? So that's a nice way to double check that you've got the correct mean and standard deviation, that you've calculated it correctly. All right, so I've got the mean of x and I've got the mean of y. Or sorry, the standard deviation of x. What if I want to just, for the sake of fun, do the same thing for y? What would I do? Well, it's essentially the same thing, just with less calculations, because now I've only got two different values it can be. Y can be 2 and y can be 6. And the probabilities are different. It's 2 80% of the time, and it's 6 20% of the time. So 2 times 0.8 plus 6 times 0.2, well, that just works out to be 2.8. All right? And the standard deviation of y, we've got one less thing to worry about over here as well, because there's only two values. The two values are 2 and 6. The mean's different. Now it's 2.8. And the probabilities are different as well, because it's 2 80% of the time, and it's 6 20% of the time. When you work that calculation out, it works out to be 1.6. Now, I like to double check my work, so I'm going to double check that on my calculator real quick here. I'm going to go back to my lists, and this time I know I've only got a 2 and a 6, so I'll delete that one. And I've only got two probabilities as well. They are 0.8 and 0.2. So when we calculate it, I'm going to use stat calc, and it's one variable, stats, and I just have to specify that my values of y are in list 1 and my probabilities of getting those values are in list 2. Sure enough, the x bar, which is the mean of y in this case, is 2.8, and the standard deviation is 1.6. So I'm feeling pretty good about those two calculations. The last thing I kind of want to talk about here is, what would you do if, say, you were going to combine these variables? So, like, what would the new mean be? What's the mean of x plus y? And furthermore, what's the standard deviation? When you do x plus y. Well, it turns out these aren't too complicated either. If I was just trying to combine these two random variables by adding them together, the mean of x plus y, that combined random variable, is simply the mean of x plus the mean of y. 3.4 plus 2.8, well, that's going to work out to be 6.2. So that's pretty simple if you're going to find the mean. But when you're trying to find the standard deviation of those combined variables, that's a little bit different. Because what you're going to need to do is you're going to need to take the two separate standard deviations. You're going to need to square them. So take that 2.44, square it, add to it the other standard deviation, 1.6, square it, and then you have to take the square root of the whole thing. So the square root, the square root of, in this case, 2.44 squared plus 1.6 squared, it's just about 2.92. So the combined variable x plus y. The mean is simple. You just add them. Standard deviations, a little bit different. Square the standard deviations, the individuals, add them together, then take the square root. What if I change that just slightly? What if I want to know the mean of x minus y? Well, that's going to change this calculation, because then it's going to be 3.4, the mean of x, minus 2.8, the mean of y. That makes sense intuitively, and that would just be a difference of 0.6 there. So the combined random variable x minus y is 0.6. But what about the standard deviation of x plus y? Or sorry, x minus y. How does that change? Well, it turns out it doesn't. It's actually the exact same calculation. The standard deviation of x plus y is going to be the same as the standard deviation of x minus y. You still square them, add them together, and then take the square root. So that's an interesting case where the standard deviation of x plus y, standard deviation of x minus y are actually the same. That's all I really want to talk about random variables today. Thanks for watching. Let me know if you have any questions in the comments.